Great. Now, we could keep going. We're going to play this game for a while. I think most of us know our squares up to like maybe 10 or 11 or 12. Okay, but this is enough for us to illustrate something unusual. Okay, which is that, look, for these numbers, you can go this way and everything's nice and neat. But there are loads of numbers, loads of square roots that aren't nice and neat. And here's where you're going to need your calculator. Okay, so let's just pick out a number. Like say, between 4 and 9, there's the square root of, say, 7. The square root of 7. Okay, now when you took the square root of 1, square root of 4, square root of 9, square root of 25, they're all nice numbers. But if you get your calculator out, and I would actually like us to punch this in, you'll find the square root button sort of towards the top left in one of those small grayer buttons, not the black ones. When you press equals, you get a weird, funky number. Can you see that? What do you get? So I'm going to write what I've got on my screen. I'd like you to do the same. Okay, I've got 2.645751311. Okay, does that match with what you got?
Yes.
Good, excellent. Okay, so far we can press buttons on our calculator successfully. Now let's notice a couple of interesting things here. Firstly, even though your calculator doesn't say it, like this is literally what my calculator says, your calculator actually means something a little bit different. And this is a really important thing. It's so important, I'm going to put it in another color. See how I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9? Did I count that right? 9 decimal places. Okay? But the square root of 7 doesn't actually have 9 decimal places. That's just as many as my calculator can show. So what the calculator means, and you should put this in like another color as well if you've got one, is dot, dot, dot. Right? The number actually keeps going. And it goes on forever. This is very strange, okay? If my calculator had a bigger screen, and in fact, later on, not right now, but if you have a phone and you turn it sideways so that you can see more digits on it, you should get more than the 9 digits that your calculator shows you, right? This is very unusual. Let me show you why. We've looked at decimals before, right? We've looked at decimals, and some decimals are really nice and neat, okay? So, examples, right? If you remember, think back to fractions last year, okay? Lots of fractions can be written as a nice, neat decimal. For example, a half. What's the decimal version of a half? Yeah.
0.5.
Yeah, very good. 0.5, okay? Now, because the decimal point, it just stops. There's no more after that. We call this a terminating decimal. Terminating, because, you know, like if you've been on a train, it's like, this train terminates at this station. So it's stopped. It doesn't go any further. Terminating decimal. There are other fractions, though, where the decimal doesn't terminate. It keeps going, right? For example, just after a half is a third. Okay? So if anyone knows a third, when I write the decimal, what does it look like? Yeah, the button. Very good. So 3, 3, a whole bunch of 3s. Just like this, you go dot, dot, dot. Bless you. Okay. There's another, by the way, there's a shorter way of writing it rather than writing a whole bunch of 3s. Does anyone remember? Yeah.
Yeah, you do like a dot on it.
Very good, yeah. So we call this dot up here, because it's making that digit repeat over and over again, we call it a repeater. It's a repeater. So that guy up there is a repeater. And I heard the word just now. Rather than a terminating decimal, this decimal goes on and on and on forever. We call it a recurring decimal. Okay, now, I'm trying to show you why this is so weird that this kind of number up here, it goes on forever. Because this goes on forever as well, right? Let me give you a musical analogy, because I like music. A terminating decimal. What's a terminating decimal? If you imagine a terminating decimal like a piece of music, okay? It's kind of like a pop song. How long is a pop song?
3 minutes.
3 minutes, 4 minutes, 3.5, something like that, right? Very seldom will you get a song much longer than that. My point is, though, it starts and it ends. That's it, that's the song. Okay? A recurring decimal, if it was a piece of music, I kind of imagine, like, you know, if you ever get into, in a hotel, a nice fancy hotel, if you get into an elevator, right? It's not quiet. There's music in the background and it's kind of this, like, quiet, it's like, and it's like this sort of, it just goes on forever and ever. If you get out of the elevator and you come back an hour later, the music is still going, just like this decimal is still going, right? So I call this elevator music, right? Now, it's important that it's, you know, it's like an elevator, because if you go in and you listen, it's still the same music. You're like, I recognize this. It's just on a loop, over and over and over again. Okay, now let's compare that now to our weirdo friend up here, the square root of 7. Okay, the square root of 7. Excuse me. If you go and write down these numbers, the weird thing about this is that, well, we already noticed it doesn't terminate, it keeps going. But it doesn't do this either. It doesn't recur. It doesn't repeat. You can't do this repeater thing. You can't put a dot on any of these numbers here. If I kept going, and I will actually for the sake of illustration, if I had a look at what the rest of the numbers were, I'm going to keep getting different numbers. Right? So let me just pull this up. Excuse me. Clear. Okay, so my calculator's got a few more digits on it, not my phone rather. Not that many more though. It goes, you might like to write these down with me, 0, 6, 4, 5, 9, 1, dot, dot, dot. Now, you might see, excuse me, there's a couple of repeats, like look, I've got 6, 4, 5 again. That's kind of weird. But even though that little chunk is repeated, it goes different again, right? And in fact, it never completely repeats. Just think about how weird this is for a second. Terminating decimal. This is a recurring decimal, right? This is just a decimal that never ends, doesn't have a really special name. What kind of music would this be? How many of you play a musical instrument? Hands up straight. Cool. What music? What instrument do you play?
Bass guitar.
Bass guitar?
Sax.
Sax?
Trumpet.
Trumpet? Electric guitar, fantastic. I'm acoustic guitar, by the way. Yep. Trumpet and... Oh, I already knew that. Great, thank you, keyboard. Now, just think about all those instruments, right? For some more than others, particularly because I know... Come in. Hello?
Sorry.
That's okay, take a seat. Do you have a slip?
Sorry. No, I just couldn't find the course.
That's fine, take a seat. There's chairs over here if you like, or that's fine. Lost my train of thought. We were talking about instruments, weren't we? Yeah? Okay, good. For some instruments more than others, and because I also happen to play it, I know for a fact the bass guitar, more than most instruments is a bit like this. It's a bit like this, right? And it'll just play sometimes for a whole song, it'll play the same 4 notes over and over again, right? So some instruments repeat, but some instruments and some styles of music are kind of like this. If anyone plays jazz, right? Jazz music is renowned for being built on improvisation. Like they're making stuff up. They don't have like a big sheet in front of them. They're like reading off the notes. They're literally inventing the music as they go. Okay. This guy here, right, is not just like jazz music because he's making it up as he goes, right? He's like a crazy, immortal jazz musician. Okay. Because think about this. He's making up new music, and he's making up new music forever. That's crazy. How long can you play new music for? I've been playing music for, how old am I? I've been playing music for about 22 years, okay? And with all of that musical sort of, in my head, I can play maybe like 3 or 4 hours of constantly new music. And then eventually I'll be like, I'll forget and I'll revert back to something that I knew before. But these guys, right? And in fact, lots of numbers like him, an infinite number even, they just keep on, and I'm ... They just keep on making new music forever. That's nuts, okay? So, we have this kind of number is a really important class of number, and is called a surd. Okay? These numbers here, which involve square roots, and they don't simplify out nicely. They're not like the square root of 4, or the square root of 9, or the square root of 25. We call them surds. Okay? Now, there's one other important label that I'm going to give these, and labels are important in maths, as in every subject, because they help you describe things. It's not because we want you to memorize terms, it's because now I can talk about these and understand them better, right? See how these are fractions, right? A half, a third, they're fractions. Another word for fractions that starts with an R, I don't know if you remember it, is a ratio, right? It's like a ratio between 2 different numbers, between 1 and 2, or between 1 and 3. Surds can never, ever, ever be written in the form of a fraction or a ratio. You just can't do it, right? It's not like, the square root of 7, it's about 3/4, or about 7/4, or whatever, right? There's no fraction that is equal, no ratio that it's equal to. So we call them irrational. Irrational numbers is the full name. Okay? So not irrational like, you're being irrational, you crazy man. We mean, you can't be like a ratio. Can't write in the form of a fraction.